what it says. All right. The national park charges $26 per adult and $16 per child for rafting down one of their two rivers. Write an algebraic expression that can be used to represent the total cost for adults A and C for children. So what would we have?
Can I answer this?
Sure.
Okay. What we have, your screen's blurry.
No, really? I'm getting there. It just doesn't want to cooperate.
Well, let's focus.
I am trying to focus it. It's got a mind of its own. It doesn't want to focus. There we go. All right, so what would you write?
So what I'd write is, so a national park charges $26 per adult. That's good to know. And $16 per child. Also good to know. For rafting down one of their two rivers, write an algebraic equation. What can be used to represent the total cost for an adult and C children ride down the wild river. So what we do is 26 times A plus 16 times C.
Correct. So 26 times A plus 16 times C. That is correct. All right, so once again, lesson 15:1. Lesson 15:1. And that is on, again, page 465. 465.
I'm on 465. Miss Lavelle?
Yes.
So our teacher assigned a science assignment, and I'm like, there's this little thing. There's a rock called shale, and after 2 million years and 61,000 weathered rock, which is basically how much has been weathered, it still is not finished. Actually, it is finished. It's just taken a very long time.
What?
Shale? Shale doesn't really take that long. It's like a weak rock.
I know. When you go for granite, it's longer.
Mm-hmm.
This is when I got year 2,150,400. Weathered rock 61691. That's how long it took for that rock to get fully done. And it used to be this. So 2 million years later, it's done. I wouldn't even be alive.
Okay. So let's look at, let me zoom it out. All right, so today we are going to explore mean and fair share. Okay, so what that means is if I found, I don't know, a bunch of coins, and let's say Miss Williams found a bunch of coins, we would combine them together and we would divvy it up so where each of us ended up with the same amount of coins. That's kind of what fair share means. Okay? All right, so our objective is to find both fair share and the balance point of the data set using a model or a number line. So it says a florist needs to make 10 bouquets with 40 carnations, 36 red roses, 24 yellow roses, and 24 lilies. How many flowers should there be in each bouquet so that each bouquet has the same number of flowers? So for the Spark Your Learning, we don't have to have the same amount of carnations, the same amount of roses, and the same amount of lilies. Just flowers in general. Okay? So what would we need to do so that each bouquet had the same amount in each one? What would we need to do?
We can add.
Okay, so
Add all the flowers and then divide by 10.
Yep, so 40 plus 36 plus 24 plus 24. So what do we get?
Can I answer this one?
So 40 and 36 is 76, right? And then I know 24 and 24 is 48. So what does that give me?
It gives you 76 plus 48, which equals 6 plus 8 equals 4. Carry the 1. 124.
Okay, and then we're going to do what Gia says. So we're going to take the 124 and we're going to divide it by 10. So 10 goes into 12. One time, right? 2 left over, bring down the 4. So 10 goes into 24 how many times?
Twice.
Twice. So that would give me 20, and I had 4 flowers left over. Okay? So we would have 12 flowers.
Each bouquet.
Yep, in each bouquet with 4 left over
Wait a minute. You
flower.
can do this because if there are 1, 2, 3, 4 bouquets, you can do 13 flowers. And
But there's not 4 bouquets, there's 10 bouquets.
I meant 10 bouquets, but you could add 1 to each one, and then
But would they all have the same amount if I added an extra flower to each bouquet, each 4 bouquets?
4 bouquets, 4 flowers.
We don't have 4 bouquets. We have 10 bouquets. Okay? So if I took those leftover flowers and put 1, 1, 1, and 4, then I would have 4 bouquets with 13 flowers and 6 bouquets with 12. So I wouldn't have the same amount, right?
Yes, ma'am.
Right. So that's why we want an equal amount in each one. Okay? All right, so let me zoom it out so those that need to finish copying can copy.
So,
Gia, did you have a question? All right, so let's look at the turn and talk. So the turn and talk says, suppose the florist has to put the same number of each type of flower in each bouquet. So now we want the same amount of the flower. So I want a certain amount of carnations, a certain amount of red roses, a certain amount of yellow roses, and a certain amount of lilies in each bouquet. So what would we need to do now to figure out how many of each would go into each bouquet.
You would need to.
Some carnations, red roses.
So there's 12 things of carnations, 12 things of red roses, and
No. We have 40 carnations.
40 carnations.
So how many of those do we need to put into each bouquet? How do we figure that out?
Well, 40. Well, we have to add. We have to add each of those.
We have lilies.
Yeah, I ran out of room, so I'm going to squeeze it over here. All right, so how would I figure it out? I got 10 bouquets.
10 bouquets.
So how many carnations do I need to put?
4 each.
Okay, how did you get that?
40 divided by 10 equals 4.
Yeah, so I would need 4 carnations. All right, what about red roses? 3, right? And we're going to have 6 left over. All right, what about yellow roses?
2 and 4 left over. Add the.
Yep. And then what
6
about
and
lilies?
2.
Yep,
And
same thing, right? And 4 leftovers. We're not worried about the leftovers. All right, so each bouquet would have 4 carnations, 3 red roses, 3 yellow roses, and no, not 3 yellow roses, 2 yellow roses. Sorry about that. And 2 lilies. Four carnations?
So I did like 4 carnations. I did 4 C, 3 RR for red roses, 2 yellow roses for yellow WR, not WYR.
I
And
gotcha.
4 lilies.
That's
2
fine.
LL.
You abbreviated, so that's fine. That works. All right. We ready to move on?
Yes, ma'am.
All right. So, now we're going to talk about fair share. So if everyone has a fair share of a group of items, they all have the same number of items. So while at the beach, 3 friends found 6, 1, and 5 shells. The friends agreed to divide the shells evenly. How many shells should each person get? Look at the model shown for each friend to have the same number of shells or a fair share of shells. What needs to happen? So what do I need to do?
We can add the 1 shell to the 5, and then we could get 6 and 6, and then we can like split it into evenly equal groups.
Okay.
And 3. Wait, can I please say something about the math problem?
Sure.
But like Gia said, add the 1 to the 5, make it 6. But if you add the 6 to the 6, you can divide that by 3 and get each friend 4.
Correct. Okay. So we could do that. So we could add them. So we would have 5, 1, and 4.
Miss Lavelle,
Yes.
so I got kicked from the meeting, but I'm back now. I only got kicked because somebody in my house was messing with the electricity box, and it just all cut off.
Okay. Sorry, it should be 6, 1, and 5. My bad. Okay, Brandon, that's fine. All right, so we would have 12, right?
Mm-hmm.
And
Divide
then,
that by 3.
yep, divide by 3, so each person would have
4.
Okay, yep. All right, so it says, explain how you could rearrange the shells. So if we started with 5, I'm just going to draw dots to represent the shells, right? If you want to draw circles, you can draw circles. Doesn't matter. All right, so technically what I need to do is we need to move 2 shells here, right? And then we need to move 1 shell from here to there. So once that happens, we would have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. We're on 466 now, but we did 465 already. Somebody still have their hand up? Gia, you still have your hand up. You have a question?
Sorry, I keep forgetting to put my hand out.
Oh, all right. All right, so then C says, suppose the 3 friends find 9, 1, and 5. How many shells would each person get? So what will we need to do?
We need to add 9 plus 1 plus 5, get the answer. 5 plus 1 equals 6, plus 9 equals 15. 15 divided by 3 equals 5.
Yep.
Boom.
Okay, so 5 each person would get. 5 shells. All right, so it says, is there another way to find fair share of shells each friend should have in part C? So instead of adding them, what can I do? What did we do up here?
You can take 3, multiply it by 5, or, sorry, I'm just doing this one.
So how would we know, if we didn't divide, how did we know there was 5 to begin with?
If we didn't divide, the common fact,
Actually, rearrange the dot.
Yeah. So we would
Rearrange.
take how many from 9?
we would take
4.
Yeah, so take 4 from 9 and add it to the 1. We don't need to do anything to the 5, right? Do nothing with the person that has 5. So take 4 from the 9 and add it to the 1, and we do nothing to the person who has 5. Kane, did you send me a message?
When is the test about this?
Do what? What's the what?
When's the test about this?
For 15-1? I mean, for module 15? I don't know. We're going to do 15-1 today and 15-2 tomorrow. I don't know. I don't know how many lessons 15-3 has. Hold on. So 15-3 is 2 days. 15-4 is 2 days. So it probably won't be next week, but the week after.
Oh, man. What if I get all of them done?
You still can't take the test early.
Okay.
All right. All right, so now let's talk about fair share, or talk about balance points. So how can you find a balance point? Celeste, I understand that, but I need you to stay into the lesson, and then once we get to the on your own, then I will let you go. Okay? All right, so it says look back at the data point in task 1, part A. So task 1, part A was the 6, the 1, and the 5. Okay, so that was 6, 1, and 5. Complete the dot plot to complete the dot plot to represent the data. Okay, so 6, 1, and 5. Okay, so now it says circle the number that represented the fair share. So if we go back and look, what did we have? What was my fair share?
4.
4. So I'm going to
circle 4.
Yep, so I'm going to circle 4. All right, so to figure out, so it says, what is the distance from each data point to the fair share number? All right, so from 1 to 4, my distance is 1, 2, 3. So from 1 to 4, my distance is 3.
It's 3.
Okay? The distance from 5 to 4 is 1. And the distance from 6 to 4 is 2. So it says, what do you notice about the total distances from the data point on the left side and the right side of the fair share number?
Well, it's going from 1, 2 to 3. First off. That's what I'm noticing.
Okay, but it says total distance. So what is my total distance on the left side?
On the left side is 4.
This is the left side. What's?
3.
Yes. Okay, on the right side
is 1.
1 plus 2, right? So what's 1 plus 2?
3.
So what do you notice?
It ends up with 3.
So we have 3 on the left and 3 on the right. Okay? So what do we notice?
We notice that it's normally there's 3 on the left and right.
Right. So the distance from the fair share on each side should equal equal the same number. Okay, so here I had 3. I added 1 plus 2 and I got 3. So from the fair share, each side, the distances when I add them together should equal the same number. Alrighty, and then D's easy, right? D says a balance point is the data set, I can't even read. A balance point of a data set is the point on a number line where the data distribution is balanced. What number from the dot plot in A represents the balance point? We circled it. What number is the balance point? Yes. So 4 is the balance point. And if you wanted to go further, 4 is also the fair share. That's what we decided on the other side. All right, and then the turn and talk says, how is fair share and balance point related? Well, what did we just figure out?
That 4 is the same.
Right, so the fair share and the balance point are the same. So they are the same. So it is the number that each person receives, right? So 4 was the balance point and 4 is the fair share. All right. So move on to the check. Move on to the check understanding. Okay, I'm going to give you 5 minutes to work on that. You probably won't need 5 minutes. If you finish before time is called, move on to the on your own. Okay? We're doing the on your own today. You will not have tomorrow to finish the on your own. It's only 3 questions. So you should be able to finish it.
I have done the on your own.
Okay.
So.
Okay. Once again, let me check. Okay? But guys, in the middle of a lesson telling me that you guys have already finished this, I'm not going to stop and look. Okay? All right. So 5 minutes. Work on. Have 7, 5, and 9 marbles. The friend agreed to divide the marbles evenly. How many marbles should each person get? So what are we going to do?
Okay, so we are going to add 7 plus 5 plus 9, and then that will get us to 21.
And then
21 divided by 7 equals 3, and that's how many marbles each person gets.
Yep, so we should have 7 marbles. All right, so what is the balance point of 3, 7, and 8? So basically, what's the mean, right? The average.
It would be 8. Or, sorry, so 3 plus 7 plus 8 equals 20.
Nope.
18.
Thank you, Gia. Equals 18.
Oh.
Divide by 3, what do we get?
Equals
6. Yep. So that's what you should have. 7 and 6. All right, so move on to the on your own. If you need help, let me know.
I need just a little help.
Okay.
Sorry, first.
Huh?
I just need help on number 4.
Okay, so did you make the dot plot?
Yeah.
Okay, so we should have what? 3, 1, 8, 4, 6, and 2 8s, right? All right, did you add all these together? Or did you add 3, 1, 8, 4, 6, and 8 together?
I'm adding them right now.
Oh, okay. All right. And then how many data points do we have?
5.
Okay. So what do you get?
6.
So that is your balance point.
Thank you.
Mm-hmm. And then how did we find it? We added them up, divided by the number we had. Oh, wait, something's not right.
No, that should be right. It would be 6, actually, underneath 30, because there's 6 numbers.
Yeah, so if it's 6
So
numbers,
the answer would be 5.
yeah, I was going to say something's not right. We have 6 numbers. So then 30 divided by 6 is 5. Okay, but the process is still the same. Add them up, divide by the...
Divided with the number I had. That's what I put for mine.
Yep, add them up, divide by the total data points.
Miss Lavelle.
Yeah.
So, on number 3, did you say that it's 5 people they're sharing with because you're counting him?
Yes,
Okay.
that is correct. All right, so someone said 3B. So it says, how should Felipe distribute the fruit so everyone gets the fair share? Well, so that's what we did with the shells. So if I have 2 and I have 7 and I have 2, how do I move the 7 so that everybody would have the same amount of fruit? So if we found how many pieces up here, right? So 7, 2, and 2
15.
plus 3 plus 1. Yep, we get 15 divided by what? 5. So how many things of fruit do we have per person?
3.
Yep. So how can we show us shuffling these around so that everybody would have the same amount? So I could draw an arrow to here, 2 of them, right? And then I could draw an arrow here, and then I would just need 1 more there. So that would give me 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and then 1, 2, 3. So 1, 2, 3, 4, 5. 5 people. So that's what they're asking you to do. So give me 2 points over here that you want to use.
1.
Are you going to use 1? All right. All right, so how many points away is 1 from 12?
11.
Okay, so that's 11. I'm going to write it up here. And then I need another point on this side. Now, you know that means your other side of your number line is going to be really long, right?
Mm-hmm.
So give me a second point over here.
10.
All right, so then from here to here is only 2. So total is 13 points. Okay? So 13, I'll try to draw as much as I can. 14, 15, 16. So that means the 3 points that are over here have to total a distance of 13 points. So maybe could we use like 16 and 16? So that would be 1, 2, 3, 4. So that would be 4 and 4, which is 8. And then I need another number that is 5. So 17. So 1, 2, 3, 4, 5. Yep. So your numbers would be 1, 10, 16, 16, and 17. So that would be 4, 4, and 5, which is 13. So that is how you would do that one. Now, could you have someone else have a completely different number line? Absolutely.
Yeah, it's open-ended.
Yep, it is an open. That's why it says open-ended.
I'm going to turn this into math.
All righty.
I'm turning mine into focus.
Okay.